Hi everybody. Sorry this is taking a while. I had a little sound problem. I don't know if you noticed that the last YouTube video that I uploaded to try to do this, it didn't work. The sound wasn't working. So I think I have that solved right now. It looks like it's registering sound. Tables of value. This is a table of values. This should be no stranger to you. You've seen this before, except usually with X and Y. So let's say this is a person working. Let's say this is Kiara at her job. Kiara. Is that? Kiara, I forgot to spell the last three letters of your name. So let's say this is someone named Justin. Okay. So, working at a job, how much does he make? Well, what we want to find is the IV, which is the initial value, and the rate of change. IV is what you start with. So out of the two things, what we always have on the left is the independent variable. What we have on the right is the dependent variable. So this one depends on that one. The amount of money you make depends on how much you work, not vice versa. If you work 0 hours, you make nothing. So when Justin works 2 hours, he makes $30. 4 hours, he makes 60. 6 hours, 90, etc. You may think, why do I need all this mathematical nonsense when I can just see he makes $15 an hour? We're starting off with a very easy example. It can get much more difficult, so we learn the tools of something easy first. Okay. So remember finite differences? When you look at the dependent variable and you look at how much is changing each step. So the first step, 30 minus 0. Let me erase this. This is from a no, that's fine. How much is that? That's 30. Okay? The second step, 30 to 60. 60 take away 30. It's always the second one minus the first, third minus the second. Okay? This distance will also be 30. We're going up by 30, up by 30. Okay? How much are we going up by here? 0 to 2, we're going up by 2. 2 to 4, we're going up by 2. 4 to 6, 2, 6 to 8, 2. Each case we're going up by 2. Well, first of all, the IV is where you start out with. So the very first value, when this is 0, the independent variable, what is the dependent variable at? It's at 0. Okay, so the IV is 0. It's always where you start with. Wherever 0 is here, whatever value you get there. It's not always 0. Sometimes it's something else. We could be talking about your bank account. And we're looking at your bank account from today onward. Today you start off, you have $15 in your account. That's the initial value, wherever you're starting the account. Okay? Now the rate of change, we're dividing this number by that. It's as easy as that. How much are we increasing by? 30. How much are we increasing here by? 2. This is dollars, that's hours. 30 divided by 2 is $15 an hour. Dollars per hour. And a rate is always something per something. That's the dead giveaway. Okay. And you always have the dependent variable on top, the change in the dependent variable divided by the change in the independent variable. That's the fraction that comes out. Let's try another one. I got some beautiful examples here. Let's do one where it's just X and Y. Okay. Independent, dependent. When we get back to the usual graph with mathematics, we have the x-axis and a y-axis. X-axis. y-axis. This is the independent variable, x, always horizontal. So if we have something else here, some other letter like A, that would be A along here. Always corresponds. The left corresponds to horizontal axis. The right corresponds to the vertical axis. Okay? So now I'm going to put in some x values. Let's say we have in this table 1, 2, 3, 4, and then it keeps on going on. And then the y goes 5, 10, 15, 20, 25. Okay, so how is this changing? It's going up by 5. I'm putting that plus there to remind me sometimes it goes down as we go on. Okay, this is going up by 5, up by 5, up by 5, so on and so forth. This is going up by 1, up by 1, up by 1. Okay, so now, what's IV? IV is what you start with. What do I have when the independent variable is 0? When x is 0, what's the y? 5. Okay? Now for the rock, the rate of change, we're going to look at the differences. This goes up by 5, this goes up by 1. If you know that this table of values is representing a linear relationship, what is linear? Linear is an adjective for line. So if it's line-like, it's straight, if it's just a straight line. That's what we're learning right now. So I'm only giving you tables of values that have straight lines. In that case, you don't have to keep subtract or looking at these differences here. Just take the first one. Goes up by 5, that goes up by 1. Done. Okay? Rate of change is 5, and that's 5 y units for every 1 x unit. Initial value is 5. So in a way, all you have to do is look at these first two. Alright? And for the rate of change, you could look at any of these. I could look at this interval here. This goes up by 5, that goes up by 1. 5 over 1. Because it's going to be the same the whole time. If it changes, this is 5, then it's 7, then it's negative 3. That's not a straight line. Okay, that's the subject of another course. Try another. Get rid of this. Okay. Now we have, time and temperature. This can be a happy example, or it could be a sad example. What's time measured in? Minutes. Time is measured in minutes. Okay. It's happy if with time, if the temperature is going up. If you like warm weather. If you like cold weather, maybe it's happy if the temperature is going down. Alright, so we start off at 0 minutes. What's the temperature outside? It's 91 degrees Fahrenheit. Well, that's pretty good. That sounds a pretty warm day, if you like warm days. Then, 30 minutes later, we look at the temperature, and it's now 85 degrees. Okay, then the next one is 60. An hour later, temperature is 79. And then 90. Temperature is 73 degrees. Okay. Well, time is independent. Independent is always along the horizontal axis. So now, this is no longer the x-axis. It's the temperature, time. This is the time axis. Always on the right, we have the dependent variable. So this is temperature. Okay? And when time is 0, whenever we start the count, that's the initial value. And the initial value is always whatever the dependent variable is when the independent is at 0. So it's 91 degrees. Always good to include the units. The rate of change. Well, we want to find the rate of change, so we want to see how much is this changing by. Now, this is going down instead, because remember, you always take the next one divided by the one you're on. So 85 take away 91 gives you -6. Ooh, that don't sound good. And then here it goes down another -6. Here it goes down another -6, and so on. Okay? Over here, well, here it's increasing by 30 minutes, by 30 minutes, by 30 minutes. Okay? So the rate of change, too much stuff. Let's put it over here. I want it a little separate so we see what we're doing. Remember the rate of change. You take these numbers, the finite differences in the dependent. That goes on top. -6. On the bottom is +30. Is -6, this is degrees Fahrenheit. I'm going to put it in here. And 30 minutes. Okay, so how's this temperature changing? -6 over 30. Well, I want to simplify that fraction. A negative divided by a positive will give me a negative. Overall, a negative. 6 divided by 30, if that's going to be 1 over 5 or 0.2 degrees Fahrenheit per minute. The temperature is changing. The rate of change is 0.2 degrees Fahrenheit every minute. I don't like it. I don't like the cold. I like the warmth. Which do you prefer? Now I sound like Mr. Rogers. Do you like that? I think you're too young for Mr. Rogers. Probably a good thing. Anyways, so this is our IV rate of change. Psst, no problem. In fact, if you're lazy, and mathematicians are lazy, mathematics is all about laziness. They're the laziest people that have ever walked the planet. Why? They want to find shortcuts. They want to find patterns. Make things easier. Okay, so let's erase this. Let's do one more. Now, the other thing I want to point out is, this is the third example we've looked at, and sometimes the initial value is 0. When the initial value is 0, they call this direct variation. Hopefully you remember that from grade 9. If not, no big deal. Here we are, grade 10. One more time. Okay. If the IV is not 0, if it starts off at something else, not 0, like 91, it's called partial variation. Partial variation. Partial variation, direct variation, partial variation. These words, you know, there's going to be a little bit of vocabulary always with mathematics or any discipline, so that's it. 0 is direct, not 0. Anything other than 0 is partial variation. In the next video after this, I'm going to show you what that means in the graph. Let's erase this. This is a chilling example. It makes me cold just looking at it. I'll leave that. Sure. Let's put a little... Put that on there. Okay, now distance. Okay, here we are in a vehicle, and we're going a certain distance. That's my independent variable. And I'm going to look at the distances in kilometers. And I'm going to look at fuel consumption. So how much gas are we burning? Gas, and it's in liters. Okay. So I've gone 0 kilometers, and starting off, I got 50 liters of gas, and I'm going on a little trip. 50 kilometers later, I have 44 liters of gas. Okay, and then 100, after 100 kilometers, I have 38. After 150 kilometers, I have 32. Okay, so how much is this changing? This is going up. I'm increasing the distance each time. How much am I going up by? 50. How much am I going up by here? 50. 50. I don't have to keep doing this. I'm doing this because I'm the teacher. I want to show you. You only got to do it the first time. That's it. Right there. And if you do it right there, that's the only one you're going to do. Make sure the difference you do is only this first one. Don't say, oh, that's a jump of 50. What is it over here? I don't care what here. I'm concerned about this interval. Okay? 50 to 44, we're going down by 6. Negative 6. 44 to 38, I'm going to keep going just to show you the same pattern. Negative 6. 38 to 32, negative 6. What is the initial value? What do we start off with? 50 kilometers. Sorry, 50 liters of gas. IV equals 50 liters. What is the rock? The rock is negative 6, change in the y, the dependent variable, divided by the change in the dependent variable, all over positive 50. That's the weirdest looking plus sign. So what is that? What's a negative divided by a positive? It's a negative. What's 6 divided by 50? 0.12? I think. Is it? Let's just leave it as a fraction. We can divide both by 2 and we'll get 3 over 25. Yeah, that's fine. 3/25, or 3, on the top we have liters every 25 kilometers. Okay? Now, is this direct variation or partial variation? What's the initial value? It's 50. If it's 0, it's direct. If it's not, it's partial. So this is partial variation. IV is 50. Rate of change, negative 3 over 25 liters per kilometer. Okay? So easy. No big deal. You can do this. So on your assignment, which is going to cover this video, and I'm going to show you, we're going to look at this on a graph, you're going to see a bunch of tables of value and a bunch of graphs. So we're done for now.